Okay, so I have started recording and it's also getting live streamed. So let me start with the some fundamental concepts which we covered in the previous sessions. One of the most fundamental concept is the concept of physical server versus virtual server. So I'm just playing this video. This is a quick 3-minute video. Will give you great ideas about use cases for when a physical server is more suitable and when is the virtual server more suitable. So this will be a right beginning for this session, and this will also
Welcome to our comprehensive guide on physical versus virtual machines. As the world becomes more digitally connected, it's essential to understand the technologies that make this possible. Today, we're going to be delving into the fascinating world of physical and virtual machines. We'll demystify what these terms mean, their key differences, and where you might encounter them in your daily tech life. Whether you're a tech enthusiast, a professional in the IT industry, or just someone curious about the tech that powers our world, this guide is for you. Get ready, because we're about to dive into the technological evolution of these machines in this video. Physical machines, also known as bare metal servers, are the traditional way of running computer applications. They consist of a single operating system and a set of hardware components, such as a processor, memory, storage, and network interface cards. Virtual machines, on the other hand, are software programs that emulate a physical machine. They run on top of a hypervisor, which is a software layer that manages the physical hardware and allows multiple virtual machines to share the same resources. Here are some of the key differences between physical machines and virtual machines. Physical machines have dedicated hardware, while virtual machines share the hardware of the physical host. Physical machines can only run one operating system, while virtual machines can run multiple operating systems. Physical machines can be difficult to scale, while virtual machines can be easily added or removed. Physical machines are generally more expensive than virtual machines. Physical machines can be more difficult to manage than virtual machines. Physical machines are generally more secure than virtual machines. Physical machines are typically used for high-performance workloads, such as running mission-critical applications or large databases. Virtual machines, on the other hand, are more commonly used for software development, testing, server virtualization, and cloud computing. In general, virtual machines are a more flexible and cost-effective solution than physical machines. However, physical machines may be a better choice for applications that require high performance or security. I hope you're enjoying the content on our channel. If you are, don't forget to
So yes, this was the fundamental concept which I wanted to begin with. So let me come to the content of this session. Right. So basically, we saw that in physical machines, there is a limitation about resource utilization. So in physical machine, resource utilization is not very efficient, whereas in virtual machine, you can get better utilization of your resources. And we also saw that what are the use cases where physical machines are more suitable. For example, when there is very high performing requirements or where workload is demanding with respect to processing capabilities, then physical machines are more suitable. But for many other use cases, which is ranging from microservices to monolith and everything in between, right? So partially monolith or combination of monolith and microservice architecture for all kinds of applications, Kubernetes is right choice. And Kubernetes works on containers. In the previous session, I covered in depth about Docker and architecture of Docker and how to create package your application in the form of containers, and then how you can teleport these containers into different machines with the help of Docker registry. So anyone know looking for these information, they can watch the recording of the previous session where I have shared hands-on exercise about how can you run simple application. First, I started with a terminal application. Then also I gave a demonstration of Java application. And definitely we discussed about how to install Docker. What are the various ways in which you can learn Docker? I will be using GitHub for all my hands-on exercises. And in GitHub specifically, I will be using codespaces to demonstrate each of features of Docker or Kubernetes. So quickly introducing about GitHub and codespaces. So what is first requirement to attend this session is you should definitely have some hands-on with GitHub. So you should have an account in GitHub. So please go and create your account in GitHub. Now, next step is create a project in GitHub. So I have many projects. So one of the projects which I created in the previous session is this is Learn Docker. This contains the material, hands-on material, which we did last time. So we created simple Java application where we had main, and then we created a Docker file, ran it in Docker container, and we were able to run it in other containers in different systems. So this is one of the prerequisite. Second prerequisite is you should create an account in something called Docker Hub. So these are the two hubs where you should have an account. One is the GitHub, other one is Docker Hub. So Docker Hub is the repository or registry where you can store your images and share it with others. So I have a Java image, which is called prefixed in my namespace, which is my username at Docker Hub, and then followed by the name of the container, which is in this case, my Java image. So any container, if you want to run and manage using Kubernetes, one of the requirement is it should be available in some registry. Docker registry is the by default. So Docker Hub is the by default or default registry, Docker registry. You may have your enterprise, if you are working in some organization or company, your enterprise might have created their own Docker registry, but standard approach is to use Docker Docker Hub as the registry for all your Docker images. Now, with the help of Docker Hub, I'm just quickly introducing about Docker Hub. I've stopped installing any development tools in my local machine. I work everything on the cloud or on containers. For example, if I have to install MongoDB, I will take the container, Docker image of MongoDB, and work on this Docker container image. Any hands-on or any learning or prototyping I have to do on any tool and software, I use Docker Hub. Docker Hub is good because here you will get official images of almost all development environments and basically all the environments which are related to backend development. Now, on the other side, front-end IDEs also I have stopped installing on my machine, local machine. I use something which is called codespaces. So this is, you see here, there is option of new code space. And with this new code space, we can work on various projects. We can work on, we also get a VM. We get a virtual machine here when you create a new code space. And in this code space, you get a Visual Studio IDE installed. So I'll be demonstrating quickly about this. So let me start by creating a repository. So let's create a repository for this session before we dive into other concepts which are very fundamental for Docker and Kubernetes. So here, let me create a repository. I'll call it Learn Kubernetes. And yes, you can enter a description for this repository. So I'll say repository for playing around with K8s. Kubernetes is also known as K8s. There are 8 characters between K and S. So that's why it's called K8s. This is a short form of Kubernetes. Instead of typing the entire word, you can write K8s. You can make the repository public or private depending on whether you want to share with others or not. If you want to collaborate, you can collaborate with other users as well by giving access or collaboration access to others. So private is something which is not public, but you can have collaborators. Good practice to add readme file, which is a documentation for your project. We will be using Java or sometimes Node.js for demonstrating various features of Kubernetes. So today we'll be using Node. So I'll put git ignore file for Node. So I choose here the template for Node. Yes, it's already selected here. Git ignore file is the file which contains some configuration, and it contains a list of files which you should exclude while uploading or while committing your changes to the Git repository which you are creating. So this is about git ignore file. I'll show you the content later in this session. Next is license. License is not that important if you're just playing around or doing some prototype, but it's very important if you're working on some commercial product or commercial project. For example, if you want to start your own startup, then this becomes important, but otherwise it is not that important. You can ignore it. You may choose none, or good practice is always to use some license which you prefer. I like MIT license. I generally choose MIT license. This is mostly common in projects which are started from universities. So now once I have all these configurations or various parameters defined for my repository, I can create a repository. So this is, no, most of you would be aware of this, but yes, I'm just going through so that if someone wants to recap on this, they can, and they can also see some of the minor changes which has happened in last few years or in GitHub. So I've got the repository, I have got the git ignore file, I got all the file patterns which I would not like to commit to my repository. This becomes very convenient. So it's good to have git ignore file. I have the license file also for any project. I also get the copyright for whatever I am doing. So this is one of the advantage for any license. You see here, I'm granting everyone commercial use permission, but they should put my copyright in the product which they are doing. They can modify, they can distribute, they can use it privately without any warranty or guarantee, all the codes. Next thing is README file, which just contains some text. We'll add more text when we want to add more details about our project. But yeah, this is all the initialization related files for this repository. Now, once I have the repository, next important step is starting a code space. So I go back to the repository homepage. Here I see the plus button. I can create new code space. Now I have to choose the repository. We just created a new repository which was called Learn Kubernetes. You can type and select. If you have many repositories which you have worked previously, everything will get populated here. You can search and select any repository. So I chose the repository which I created just now. So now you can choose the branch, which is the main branch. You don't worry about this message that this is paid. You don't need to share your credit card number, and many hours of code space per month is free. So I believe 15-20 hours of code space access. I am not 100% sure. I have to double check, but I believe around 20 hours is free every month for users. So reasonable amount of no time is there. And on top of this, if you want to use more, you can pay. And that fees is less. If you have to buy new devices, you have to spend lakhs of rupees to buy a powerful laptop. But here you get at very minimal cost this virtual machine where you will get your development tools installed. And this is very convenient also. So now after doing all this setting, you have even option to choose 4-core CPU with 16 GB RAM. But I'm choosing 2-core CPU, 8 GB RAM. This is something minimal configuration which is required for Kubernetes. We should need more power. But yes, if you are installing more complicated applications, so as we will proceed, when we will be deploying a full-fledged application which is running on multiple containers, then we will be choosing more powerful device. But for now, we will be using 2-core CPUs. Now we can click create code space. And when I click, it is starting a virtual machine for me. And in few seconds, it starts the new virtual machine. And I see a Visual Studio running on my browser. So you see, this is a Visual Studio Code, basically Visual Studio Code Community Edition, which is an open source studio. This is not Visual Studio. This is Visual Studio Code. Visual Studio Code is a lightweight version from Microsoft again, but it is very flexible, and it is again based on plugin architecture. So in this, if I want to check what I get, right, it shared in the previous screen that there was various tools available. So here you will get, for example, Node installed already. So it's convenient for JavaScript developers because it comes with Node version 20.11. It also has Docker installed. So I run this and I see this. There is Docker version 24 already installed here. So you don't have to do any setup. You get everything running and set up in few seconds. You can configure this virtual machines also. You can create a template for your code space also. We'll talk about that later in later sessions, but today we will be focusing on Kubernetes and its architecture and various components. So this is what is the code space. And now this becomes very useful for building images. You can check my video recording of the previous session to learn about Docker. So now I will cover few fundamental concepts. So one of the fundamental concept I wanted to cover is container, right? So container we learned in the last class. Again, I'll be doing a recap. You saw the video about physical machine. You understand what is physical machine. It's your laptop or any hardware, which is a physical hardware. Real hardware is physical machine. Next, the computer or IT infrastructure evolved into something which is called as virtual machine. Virtual machine is an emulation environment. It's not a real computer, but you are getting a computer, which is a software emulation of the real computer, and you get flexibility. So something similar to CodeSpace environment, which we saw. It was not running on my laptop. It is running on someone else's machine, or basically it was running on GitHub Cloud. And what I was having is just the access to the coding environment. So this is about virtual machine. Virtual machine can be stopped and started. They are required. There is a term which you should note down. Ephemeral. Ephemeral is a term which is used for virtual machines, containers, or pods. This means that no, generally it's used in cloud computing or IT technical terminology. It means something which is temporary, which is short-lived. And for example, a container or a virtual machine can be created, destroyed, and again rescheduled or created again anytime. So such kind of resources are called ephemeral because they are temporary resources, and they provide flexibility and they help us scale our applications. Right. So important terms to note down for today is so these things I'll be covering. So important things to note down for today is container. Container is a lightweight virtual machine. It contains all the dependencies for running any application. So it may contain code, but yes, sometimes you don't need the code to run your application. What you need is the runtime, the libraries and dependencies. So binaries along with libraries, dependencies, or some system tools and configuration files is what is contained in a container. So after container, container also provides lots of benefits. I'll take 2-3 minutes more because it's very important to understand the fundamentals, and then we'll deep dive into more advanced topic. So I will share one more video, which is about containers. So just hold on for a minute. I'll be sharing a video which will give you a very good idea about what are the benefits of containers.
Ever wondered why the conventional methods of deploying software applications often lead to complications? How can these challenges be addressed? The answer lies in a simple yet revolutionary technology: containers. Imagine having a box in which you can pack everything needed for a trip: clothes, food, gadgets, all neatly organized and ready to go. Now, imagine if this box could be teleported to any location in the world instantly. This is what a container does for software applications. It's a lightweight standalone package that includes everything an application needs to run: code, libraries, system tools, settings, everything in one place. This concept might sound familiar if you've dealt with traditional virtual machines, but containers take it a step further. Virtual machines emulate an entire operating system, leading to significant resource overhead. On the other hand, containers share the host system's OS kernel, making them much more efficient and faster to start. But why are containers such a game changer? Well, they solve many problems that plague traditional deployment methods. Ever dealt with a "it works on my machine" issue? Containers ensure consistent environments, eliminating this problem. They also provide portability, allowing applications to run on any platform that supports containerization. And with efficient resource utilization, they can drastically reduce infrastructure costs. One of the most popular technologies enabling containerization is Docker. Docker allows developers to package an application with all its dependencies into a standardized unit for software development, known as a Docker image. These images can then be deployed as containers on any system running Docker, making the deployment process quick and hassle-free. Containers also shine bright when it comes to scalability and management. With technologies like Kubernetes, an open source platform for automating deployment, scaling, and management of containerized applications, you can handle thousands of containers as easily as handling one. But aren't containers a security risk? Not if managed correctly. Tools like Docker provide isolation mechanisms like user namespaces and seccomp profiles to ensure that each container runs in its isolated environment, reducing the risk of a potential security breach. In the world of modern application development, containers have become indispensable. They provide rapid deployment, easy scalability, efficient resource utilization, and simplified management. Whether it's a web application distributed across multiple servers or a complex DevOps pipeline, containers make it easier and more efficient. In conclusion, containers are transforming the way we develop and deploy applications. They are not just a trend, but a fundamental shift in how we think about, design, and deliver software solutions. The journey of exploring containers is filled with endless possibilities and innovations. So why not dive in and explore this fascinating world of containers?
So yes, this is a brief introduction about containers. Now we'll dive into more specific topics which are related to Kubernetes. So let me share a few important terms. So the fundamental terms which we want to learn today is pods. Now I'm diving into, we are going beyond containers. Containers are, when we talk, we mean Docker containers because this is the most popular container technology which is available, and most of the applications they are running on Docker. Now let's talk about what are pods. So pods in Kubernetes, again I'll write K8S. It means they are the smallest deployment unit. And this is something like pods has one or more containers. And containers now within a pod are tightly coupled and they work together. Right? So many times we require multiple components to be running together because just one component does not serve the purpose. So in that case, we'll have multiple containers within a pod, and these containers, they will work together and they are tightly coupled and they work together to perform a specific task. So this is about pods.